Hi there, today we're going to learn about fractions and decimals. So our objective for today is to write fractions as terminating or repeating decimals and compare fractions and decimals. A repeating decimal is the decimal form of a rational number. For example, 0.3 repeating turns into 0.333. Alright, so this is a repeating decimal. Bar notation is when a bar line is placed over the digits that repeat. So here we have the bar over the number 3 because that's the digit that repeats. A terminating decimal is when the repeating digit is 0. So for example, here we have 0.25. That's the same thing as saying 0.25000000. So in other words, the repeating decimal is just 0. Okay? Alright, equivalent fractions. Equivalent fractions use denominators of 10, 100, or 1000. When you use these denominators, it's easy to go right from the fraction to the decimal. In other words, if you have 1/2, you can see that that's equal to 5/10. All you have to do is multiply this numerator 1 times 5 to get 5, and multiply the denominator 2 times 5 to get 10. So 1/2 and 5/10 are equivalent fractions. And then if you say this 5/10, you end up getting 5/10 as a decimal. Anytime you want to convert a fraction into a decimal, you divide the numerator by the denominator. This works for all fractions. So when in doubt, just divide the numerator by the denominator. So here I have 7/8. I would do 7 divided by 8, and it's 0.875. Here I have 4/5. You just do 4 divided by 5, and you get 0.8. And here I have 3/16. You just do 3 divided by 16, and you get 0.1875. So you divide the numerator by the denominator. Repeating decimals. So here we have 0.3535353535, and it's written like this, 0.35 with the bar over the 3 and the 5. Here we have another repeating decimal. I'm just going to change this real quick to 0 because that's what I have here. So here we have another repeating decimal. We have 0.714571457145. That ends up repeating, so the bar is over the 7145. Alright, so here's a little hint about repeating decimals. If the denominator is 9, 99, 999, 9,999, and etc., the numerator repeats in decimal form. For instance, if you had 2/9 as a decimal, it would be 0.2 repeating. Notice it's 2 would end up repeating. If you had 24 over 99, your repeating digits would be 24. So it would be 0.24242424. Here we have 1/3 equals, well, you can make it have 3/9. If you do 3 times 3 to get 9, 1 times 3 to get 3, 1/3 is equivalent to 3/9. So here, in this case, it's 0.3 repeating. And that leads me to this, my disclaimer. Not all repeating decimals will have a denominator of 9 or 99 or 999. Okay, so not all of them will have that. However, I want you to notice that anytime you have a fraction that does have this, 999, 999, anytime you have a fraction that has 9s in the denominator, I want you right away to know that it's a repeating decimal. So here's some more examples. I want you to try to pause the video and do these on your own. By now you should have already done these on your own if you want to check. Here are the answers. For here, you would do 5 divided by 12, and you would get 0.416 repeating. Just the 6 is what repeats. Here you do negative 2 divided by 11, and you would get 0.18 repeating. Sorry, it's a negative 0.18 repeating. Remember, negative divided by positive gets you a negative. Here we have negative 5 divided by 6. Negative 5 divided by 6, and you end up getting negative 0.83 repeating. And here we have 7/9. You do 7 divided by 9, 0.7. And just remember, this one right here, this fraction right here, has a denominator of 9, so it needs to be repeating. Alright, here's how to compare fractions and decimals. I know you're all familiar with these symbols. This is less than, greater than, and equal to. If we're trying to compare 1/4 and 0.2 or 2/10, turn them into fraction, or turn them both into decimals, and then you can compare easily. So this 1/4 turns into 0.25. This 0.2, or we're going to keep it as 0.2. Now if you notice, we have 0.25, 2 place values, 0.2, 1 place value. Well, it's hard to compare these two, so I'm going to just add a 0 to the end of this 0.2. So now I have 25 hundredths. Now I have 20 hundredths. Well, which is greater? The 25 hundredths. If you don't believe me, you can draw out a number line and realize that 0.25 is to the right of 0.2. So in other words, 1/4 is greater than 0.2. Here is another example. You have negative 5/8 compared to negative 6/9. Alright, well let's write them first, both as decimals. So we have negative 0.625 compared to negative 0.6 repeating. Okay, well it's kind of hard to compare these two because this only has 1 place value past the decimal. This has 3. So I'm going to make sure that both of them now have 3 decimals, or 3 place values past the decimals. So I have 0.625 here and negative 0.666. And I'm going to add that the 3 dots at the end so I know that it's repeating. Okay, well now I can compare. I have negative 625 thousandths, and here I have negative 666 thousandths. Alright, well I'm comparing two negative numbers. This one is more negative than this one is, so that means that this number is less than this number. In other words, negative 5/8 is greater than negative 6/9. Again, this number is more negative than this number is. So that's why this is less than this. And if we look here, well, if we were to graph negative 625 thousandths, it would be somewhere over here in the number line. And if we were to graph negative 666 thousandths, it would be somewhere over here. So if you realize here, this number is to the right of this number, therefore this number is greater. Alright, and here are some concluding thoughts. Terminating decimals are when 0 repeats in a decimal. Repeating decimals are the decimal form of a rational number. In order to go from a fraction to a decimal, just do the numerator divided by the denominator. This symbol means less than, or more to the left in a number line. This symbol means greater than, or more to the right of in a number line. This symbol means equal to. And then to compare two numbers, turn them both into decimals. Alright, I hope you learned how to compare fractions.